Great. Warm welcome to the session about closed loop tracking. I'm super excited because I always thought that tracking was not possible on LoRaWAN. So I'm going to learn lots of new stuff during this session. But before doing that, let's do a quick introduction. I'm Afzal. I work for Deutsche Telekom, working on narrowband IoT and LTM connectivity. And now I'm handing over to the panel members.
Okay, yeah. Hi, everyone. I'm Thomas Brunner. I work for Miromico. We are an engineering company based in Switzerland. We do whole hardware design, firmware development, and scale it up until mass production. And of course, one of our main focuses lies on LoRaWAN. That's why we're all here today.
Yeah, hello guys. My name is Michael. I'm working at Truvami. I'm responsible there for the whole software part. And Truvami itself is also Swiss-based, and tracking is like our main asset or our main topic. So I'm really happy to be here and also to talk about our solution and how we overcome that issues or that opportunities that you can get with LoRa itself.
Cool. So both coming from very famous companies in IoT, Miromico and Truvami. So can you maybe explain what the heck is closed loop tracking?
Yeah, so closed loop tracking is a logistics process basically. So it tracks goods or processes in larger companies. So it's not like tracking wildlife in the forest, but it's really in a confined space, tracking known goods that have basically known ways where they go. So, for example, Swiss Post has big yellow crates where all the letters and stuff are moved in. And they stay in the building of the Swiss Post all the time. But they want to track them so they know where each one of those boxes is. So this process is a good example for closed loop tracking.
And so it's like limited to a specific area, right? A specific location.
I mean, that doesn't have to be area, but it's like can also be go out. So it's not just one factory or one yard, but basically you know ahead where your stuff will be. You just want to keep track of it, where exactly in your area it is. Yes.
Okay. Starting with Michael, do you maybe have some real life examples of these type of closed loop tracking use cases?
Yes, so in fact we already did several demos here at this conference where we do closed loop tracking as well. So we deployed gateways, so we know where they are, and based on that we can then check where is our smart label, our newest product, and we can locate it. And it's, I think, also like a prime example on how closed loop tracking can work, because we know the environment, we can prepare, and this also gives us new opportunities to track indoor with technologies that otherwise are not possible, since we don't know the environment and cannot really like control it. But with closed loop tracking or like in general with CLT, you can prepare everything and get like optimal environments.
Thomas?
Yeah, I agree. I mean, that's a prime example. I mean, I think the interesting thing about closed loop tracking is you can really take the best of all technologies that you have at your hand, because when you know your environment or the area that you want to track things, you have all knowledge you need to know to select the perfect technology. I mean, there are many tracking technologies that we use in our trackers today, and so indoor tracking, outdoor tracking, also the connectivity, all can be chosen exactly to fit the use case of the closed loop tracking.
But it is possible, right, to use only LoRaWAN for closed loop tracking?
Of course, it's possible, yes. LoRaWAN for tracking is possible. So either, of course, the connectivity, but what also can be done is what Truvami is doing with the smart label, where they are getting the location of the device just with the RSSI or the time of flight of the LoRaWAN messages that are sent. So that is very good possible, yes.
But and you just mentioned you were just naming some examples
Yeah.
of these closed loop tracking use cases.
Mm-hmm.
And are these then also running on different types of technology, or?
Of course, yes. So I mean, depending on the use case, we can use different things. So I mean, we can maybe list some of the location technologies that can be used. So I think the traditional one is just a normal GPS. So you have a GPS receiver on the device that gets the location on the device and sends the location through LoRaWAN to the cloud. That's like the traditional way. And now we've seen, of course, GNSS sniffing, where we send the raw satellite data to the cloud, where we can resolve the data. And we don't have the location on the device, but in the backend. So that's a new way. But those are usually more for outdoor. So in closed loop tracking, we also have to track the stuff inside, where we don't have GPS reception. So there we get a lot of opportunities for technologies. So this could be Wi-Fi sniffing, for example, to get a more or less accurate location, or we could use BLE beacons. So to do that, or we could use the technology with the RSSI, so we get the strength of the signal of the messages that we get and the known location of all the gateways. We can also resolve position of the device. So those are some examples of tracking technologies that can be used, closed loop tracking.
Okay, anything to add, Michael?
Yeah, so with LoRaWAN tracking or with this RSSI-based tracking, you basically get it for free, right? So it's just a normal device, and as long as it sends using LoRa, you can then like try to locate it and triangulate it as well. So you can get the location insights without any additional changes to firmware or hardware itself. So that's also something very interesting there, and I guess are a lot of opportunities there to also.
Okay, well, the way how you describe it, it sounds that it's very easy and very valuable. But are there also challenges when deploying such solutions?
Yes, so the challenges there are just in general with radio, like the interference that could be an issue, or also if the environment itself changes. I mean, if you own that place, you can control it to a certain degree. But if you have like an office, for example, sometimes maybe there are new panels or something and new obstacles in the way, which can then therefore affect the precision or the localization part. So that's a huge challenge there, but you can like do recalibration. So that's one thing how you could counter that interference.
Thomas?
Yeah, I mean, of course, there are a lot of challenges. It depends on which technology you are using. I think, one of the challenging part is, for example, big buildings where you have to get the reception into the cellar or even onto the roof, or big yards. So, there are definitely challenges. I think the most challenging part is the combination of different technologies. Because when you're indoors and you're outdoors, you can't just use one technology. So I would say the biggest challenge is the combination, and for when to use which technology, and ideally to integrate two technologies, at least one for outdoor tracking and one for indoor tracking, into one device.
So if my understanding is correct, the challenge is when it comes to, for example, one customer who wants to have a device for both indoor and outdoor
Yeah.
tracking, is that for indoor you would use Wi-Fi, and for outdoor you would use GPS.
Yes, that's one way to go at it, yes.
And I assume that it's very inefficient and expensive to make devices with both Wi-Fi and GPS location, right?
No, I mean, there are some chips that can do both at the same time, for example, from Semtech, that do the Wi-Fi sniffing and the GNSS sniffing on one chip. So there you get it for free. I think that's a very good combination and a solid choice, because you get both technologies of both worlds in one chip.
But what's then the hard part here? If it's not the hardware component, then
I mean, Wi-Fi sniffing is not that accurate. So if you really want to track one box inside of a room or inside of a hall, with Wi-Fi, you will get the location, yeah, more or less. So you know it's probably in the room, but if you want to have it more precise, you should use something like BLE beacons, or you should use the RSSI method of truvami. And there, I think the problem is mostly that you have to put a lot of gateways or beacons inside the room. So it's can be costly for large buildings, for example.
And if we look beyond closed loop tracking then for a moment,
Yeah.
so it's a surprise question. Do you see these type of devices and technologies like running on LoRaWAN? Do you also see it as a solution for global tracking?
Yes, so one of the main issues there is that you need to have LoRaWAN coverage, right? So what you can do, you can buffer locations like gathered by either GNSS or Wi-Fi, and then send them when you get LoRaWAN coverage again. So there you can like overcome that uncertainty that you have in terms of global tracking. So that's one thing how you could like optimize that and still get a complete trace even without coverage or without that closed loop, without that known region. So, and there with Wi-Fi you can still get accurate positions. And one thing you need to point out there is that if you have access points, especially on venues like this, that are brought to that place, then you cannot really trust that location. So that's also one thing that you need to consider when having like different technologies combined, right? Just to validate that position as well, to get a precise location and not something that isn't accurate.
You agree?
Yeah, I mean, there are challenges to do global tracking. I mean, one of the main problems is also the different regional parameters of LoRaWAN. So if we build a device or sell a device in Europe, it operates on the 868 megahertz band. So we're not allowed to send on that frequency if we are, for example, in Asia or in the US. And B, if we would send illegally on those frequencies, there are no gateways that capture the data. So, I mean, one topic that tries to solve this is LoRaWAN 2.4 gigahertz, which we heard about yesterday. Yeah, so we can build one device with one antenna that operates all over the world. Of course, there are some drawbacks with LoRaWAN 2.4 gigahertz, which is mainly the distance that it can cover. But yeah, with that radio technology, we're able to send and receive data all over the world. So that's one problem that was there for a long time with tracking with LoRaWAN that has been kind of solved now with this technology. Yes.
I'm really impressed because, as I said in my previous panel sessions, I'm a cellular guy.
Yeah.
Come from the NB-IoT LTM world. And in my cellular world, we always tell each other LoRaWAN is limited to certain use cases. And then 2 weeks ago, when I was preparing my other panel session, I've learned that LoRaWAN is also being used for smart city.
Mm-hmm.
You know, I always thought that, or we in the cellular world, we always thought that it's limited to specific areas, for example, farmland or buildings, while actually it's being used citywide as well. And if citywide is possible, then nationwide should also be possible, right? And then I thought, okay, so I've learned that LoRaWAN is also useful for smart city. And then I still thought, okay, but tracking is still something which is for narrowband IT and LTM.
Yeah.
And now we're discussing tracking on LoRaWAN. So I really think that you guys and also the people in the audience should shout a little bit louder in the market.
Yeah. Yeah, I mean, it's definitely true. I mean, one thing that we have to consider with LoRaWAN is also, I mean, there are multiple ways to track stuff. I mean, it depends if you need global tracking with accuracy of like a meter, or if you just want to know that something is, for example, in that warehouse in that country. I mean, stuff like that is very easy achievable because you can just set up one gateway in a warehouse in US and one gateway in the warehouse in Switzerland. And then as soon as the device, the device is in the warehouse, it can send its data, and you already know it's exactly in that position. So I think it's not needed to all the time know the exact location of boxes or crates or whatever, but just to know where it is, in which warehouse or in which building. I mean, especially in closed loop tracking, where you know your building. So if you know you have one gateway in that building, in that country, and your device is sending data from there, you know it's there. I mean, for some companies, that's already good enough. So it really depends on your use case, what you want to track and how accurate you want to track it.
And is it then, would you also say then that it's, um, like if we concentrate on your products, right, from Miromico and truvami, are these mature enough to offer it as a standard product for most of the tracking use cases, even though they are like the customer requirements are very diverse?
Yeah, so it really depends on the use case itself, because if you want like really lifetime tracking, like very frequent tracking, then you would probably still use a cellular tracker, just because you can send more often and more data in general. But if you have a device, or if your need is just like one position per day or like once per hour, then LoRaWAN tracking is a good low cost in operation alternative to cellular trackers. And with the LoRaWAN tracking itself, you can also have very low power devices as well. So they are oftentimes deployed over several years as well. So you don't need to maintain it or like recharge with a cellular tracker. So that's a big advantage I see. But for use cases where you have access to an energy source, like in a car, for example, you
Sorry, for what kind of use cases?
if you have like a fleet management in a car, for example, then you have access to power, and then you might have to reconsider. But it all changes if you don't own that car, and you don't can or you're not able to access the power there. Then you're still like dependent on a battery powered device, and then LoRaWAN tracking would be a suitable option again. So.
Yeah. I mean, speaking of the products that we have for tracking, I mean, yes, we have built in the past devices for hundreds of use cases. I mean, from BLE tracking to Wi-Fi sniffing only, or a combination of all those technologies. I think now with truvami, they have a nice set of different trackers that are probably suited for most usual use cases. And I mean, especially in closed loop tracking, where we know the area ahead, that's not really needed a special development. But for, I mean, contrary, I mean, one tracker that we did is probably the opposite of closed loop tracking. It's a GPS tracker that was put on a bird for research from a university. I mean, that's really, you just put it on, let the bird fly, and you never know where it will go. So it's, yeah, for stuff like that, you need a special solution. But if you can define the area or the processes of your tracking, the products are already here and mature enough to fit the customer's needs.
And if you look at adoption and make a comparison between closed loop tracking and global tracking,
Yeah.
where do you see more adoption at the moment? Where do you see more success?
You want to answer that, or?
Yeah.
So I think closed loop tracking at the moment is gets more attention, because it's usually the big companies that dive into topics like this first, so they can afford this step to track all their objects that they want to track, and they can afford the setup in their facilities. So I think that's at the moment the easier part, or the part that is done more, yes.
Yes, so global tracking, there are still some caveats there. So it's not that easy with LoRa in general. But as Thomas just mentioned, if there is like a gateway on multiple sites, or on one of the sites, you can like try to overcome that issue that way. and still get like global coverage. But in general sense, yes, closed loop tracking is the most, or most of the use cases are closed loop tracking when it comes to LoRaWAN tracking in general. Yes.
Okay, thanks. I'm actually out of questions, and as I said, I didn't even know that tracking was possible on LoRaWAN. So I've learned a lot of new stuff. So I want to thank you both,
Yeah.
and
Pleasure.
looking forward to the next session next year about the evolvement of tracking on LoRaWAN.
Perfect.
Yeah.
Thank you very much.